So for number 2, they give us that a particle moves along the x-axis so that its velocity at time t is greater than or equal to 0 is given by v of t equals ln of t squared minus 4t plus 5 minus 0.2 t. Now for part A, it says there is one time t equals t sub r in the interval from 0 to 2 when the particle is at rest, i.e. not moving. So when it's not moving, that means v of t is equal to 0. So first thing is find t sub r. Now they asked a second question, but first we want to find t sub r. And so what that means is that we have to set this in a graph and find when it equals 0. So I'm going to type in my formula, and in place of t, I'm going to put x squared, because that's how my calculator works. And they give us an interval. The interval is from x equals 0 to x equals 2. So I'm only going to set my x values there, and then I'm going to go to zoom, and I'm going to go down to zoom fit, and there is my picture. It's not fit very well. There, that's a bit better. Oops, clear. Let's try this again. Zoom fit. So clear 0, clear 2. Alright, doesn't want to work as well. That's okay, I'll fit it myself. There we go, that's a better picture. So there's our point right there for t sub r, which we want to find. So I go to second trace, find my 0. So I set my left bound over to here, and then I go over, and then I have my right bound to the right. And then there is my 0, 1.42561. So that is my value for t. So 1.42561. So I'll be back here in a moment. Now, there's a second question. For 0 less than t less than this value. So we're talking about 0 less than t less than 1.42561. It's asking, is the particle moving to the right or to the left? And we want to give a reason. So that means we're looking at this interval of the graph right here. Now in this interval, v is positive. So for this interval, v of t is greater than 0, which tells us the particle is moving to the right. Because when something is moving side to side, if it's a positive, it's moving to the right. If it's negative, it's moving to the left. And that's all the reasoning. We didn't have to justify how we found this. We already found that, so we didn't have to justify that. We just had to say that it's moving to the right, and this is what they were looking for, that v prime of t is greater than 0. We had to connect that idea with it moving to the right. Now, part B, it says find the acceleration of the particle at time t equals 1.5. So a of 1.5, that's equal to v prime of 1.5. So on our calculator, we're going to use the derivative feature. And we're going to type in 1.5. And so at 1.5, we get our dy dx value of -1. Now, if you looked in the problem, it doesn't give us any units. So all we can say is that. Now the second question is the speed of the particle increasing or decreasing? Now in order to know that, we also need to know what is the velocity at 1.5. And if you notice, it also gave it to us. Now on other calculators, you would actually have to trace that separately. But once we know what the velocity and the acceleration are at that point, we can say the particle is speeding up because v of 1.5 and a, whoops, I shouldn't use a. As much as they say acceleration, we shouldn't use a, we should use v prime. 1.5, let's clean that up, 1.5 have the same sign. So we have to connect the idea of speeding up with same sign, but we also have to demonstrate that by showing that we knew how to find the velocity right here at that point and the acceleration at that point. Part C, the position of the particle at time t is x of t, and its position at time 1 is x of 1 equals negative 3. We want to find the position of the particle at time t equals 4. So when the position at time 4, that's going to be the position at time 1 plus change in position. So x of 4 equals, now x of 1, that's going to equal negative 3. And the change of position, we're going to find that by going from 1 to 4 of v of t dt. Now, some people believe that you have to write out the formula here in your write-up. You actually don't, because it's understood what v of t is equal to. Now, I will not use the graph. Some people will use the graph.
At Depago.
So, instead, okay, so we'll let that add run. 19711. That's how we get that. So delete 1, 4. So we have ln of x squared minus 4x plus 5. And then we have minus 0.2x. And so there we get our value of 0.1971. And then I can take all of that, and then I can add negative 3 to that. And so we get negative 2.803, because remember we are rounding to 3 decimal places. And then finally, part D, it says find the total distance traveled. So in order to find the total distance traveled from the interval from 1 to 4, we need to take the integral of the absolute value of v of t dt. Now some people think that all we had to do is take this answer and take the absolute value of that. That's not how it works. And that's because if I graph this with a window from 1 to 4, 1, 4, okay. The integral is going to have this negative area cancel out some of the positive area, and we don't want that to happen. So what we have to do is we have to put in the absolute value first. So minus 4x plus 5 minus 0.2x. And so when we graph it now, that negative area should now be reflected over the x-axis and be reckoned as a positive. So 1 pound is 1. Right bound is 4. And so there we get our value of 0.958. Whoops, 9581. So that's 0.958. Now in some calculators it came out to 0.959, so you may have to watch it. Make sure that your calculator is in the right mode, but I presume that AP may accept either 0.958 or 959. We will see what that happens. We'll see what happens when we get the answers to come out in a few months. All right, thanks for watching, and we'll see you in the next question.